We tend to think of AI models as black boxes. You give them input, they give you output. And whatever happens in between feels abstract, mathematical, even safe. But what if that model remembers more than it should? That's the risk behind model inversion attacks. A model inversion attack happens when an adversary carefully queries a trained AI system to reconstruct parts of the data it was trained on. They're not hacking a database. They're not breaching a server. They're interrogating the model itself. Modern AI systems are trained on enormous data sets, sometimes including proprietary documents, internal code, customer records, medical information, or scraped web content containing personal data. In theory, models learn patterns. In practice, they can sometimes memorize specific details, especially rare, sensitive, or unique information. And that's where the risk begins. By sending structured, repeated queries and analyzing how the model responds, an attacker can infer hidden attributes about the training data. They might reconstruct fragments of proprietary source code. They might extract sensitive phrases from internal documents. In more concerning cases, they could recover elements of personally identifiable information. No firewalls were bypassed. No database was directly accessed. But the model becomes an exfiltration channel. Why does this happen? Because machine learning models compress vast amounts of data into parameters, sometimes billions of them. While designed to generalize, models can retain traces of what they've seen. Under the right conditions, especially if safeguards are weak, those traces can resurface. The impact is serious. Personally identifiable information can leak. Intellectual property can be exposed. Trade secrets embedded in training data can reappear in outputs. And as AI becomes embedded in healthcare, finance, legal systems, and national infrastructure, these stop being a theoretical concern. It becomes a governance issue. Organizations deploying AI must ask themselves, do we know exactly what's in our training data? Was it properly licensed and consented? Have we tested the model for memorization and leakage? Are we using privacy-preserving techniques like differential privacy or robust regularization? In cybersecurity, we've spent decades protecting databases and networks. Now we have to protect learned representations. Because in the age of AI, the breach may not show up in your server logs. It may sound like a perfectly normal answer. And that's what makes model inversion attacks so dangerous. Sometimes the most sensitive data isn't stored anymore. It's simply remembered. This has been your cybersecurity tips of the week. Everyone, please stay safe and secure. Until we see you next time.